Hello, my name is Richard Connor Hymas, and I chose to research the buffer overflow memory stack exploit. So what exactly is a buffer overflow? Buffer overflow is an error inside a piece of software that does not supply a sufficient amount of buffer for any given variable. So when a buffer overflow occurs, it means that a variable that was supplied is larger than the buffer given, and the excess amount of data leaks into adjacent memory addresses. We will discuss the ramifications of something like this happening, but in most, if not all cases, it is not ideal for this to occur. What is a buffer? A buffer is an area of physical memory storage used to temporarily store data while it is being moved from one place to another. They typically reside in RAM, and they are commonly used to improve performance and efficiency of accessing data. A common example that may resonate with everyone is how a video streaming service downloads a percentage of the video when the connection is sufficient, so that during the length of buffered video, any minor connection drops will not affect the video stream performance. Buffers can be designed to contain specific amounts of data, and programs can even have protocols that expunge any excess data so that the chances of a buffer overflow are mitigated. Otherwise, adjacent memory addresses will be written to. So how are buffers exploited? An attacker can deliberately feed specific inputs to try and overwrite known adjacent memory addresses in order to achieve a predetermined result, usually resulting in the attacker gaining a higher level of control over the program. Known areas that contain executable code can also be manipulated in a way so that an attacker's own code can be pointed to and trigger, giving the attacker their specified result. An example that can be utilized to highlight the amount of damage this exploit can cause can be seen in the popular video game system, the Nintendo Wii. An exploit was found that utilized an unchecked buffer inside The Legend of Zelda: Twilight Princess. The buffer that was exploited was linked to the in-game horse's name, so Team Tweezers developed a piece of software that could be specifically modified into a Twilight Princess save file. Upon booting the game and loading the modified save, the program would be dumped into the Wii's memory and it would be executed. This specific program would look for the Hack Me installer located on the root of the SD card and initiate that program. What came next was the Wii security was completely defeated, and this opened the door to really cool things such as homebrew programs and the like. But it also opened the gates to software piracy, which of course cost Nintendo a lot of money. It just goes to show that a seemingly insignificant check on an in-game horse's name buffer value could lead to another exploit that would give users the ability to choose to circumvent copyright protections. Question 1. Now that we have discussed buffers, the buffer overflow exploit, and some examples, I now ask, what other possibilities do you think could come from having data leak into adjacent memory addresses in any given system? So who is vulnerable? Two of the more popular languages, C and C++, are especially susceptible to these buffer overflow exploits because they offer no built-in protections, so the responsibility falls on the programmer to expunge all potential vulnerabilities. Some of the other languages, such as Java, Perl, and C#, have built-in protections to help mitigate these errors. These protections include address space randomization, which as the name states will randomly change address locations of key data areas. This helps stop these errors because most rely on knowing specific addresses that contain executable code. The second protection is data execution prevention. This makes those key data areas non-executable, so that if anything is tampered with, nothing can be executed, stopping custom, malicious, unsigned code from being initiated. Question number 2. Do you think utilizing a programming language that features built-in protections is enough to protect a piece of software from being exploited? How do you think programmers can test and determine if a buffer overflow attack is possible? There are different buffer overflow attacks that seem to pinpoint different types of data. First, there is the stack overflow attack. This is the most common type of buffer overflow attack and involves overflowing a buffer on the call stack. Next is the heap overflow attack. This type of attack targets data in the open memory pool known as the heap. The integer overflow attack is when an arithmetic operation results in an integer, a whole number, that is too large for the integer type meant to store it. This results in the buffer overflow. Finally, the Unicode overflow. A Unicode overflow creates a buffer overflow by inserting Unicode characters into an input that expects ASCII characters. So in conclusion, the buffer overflow exploit is an extremely common yet preventable error. Many programming languages have taken steps in order to combat this type of error from occurring, and the severity of the consequences that lead from a buffer overflow vary wildly. It could be something simple or something massive such as the Nintendo example we spoke of.